Hello everyone, welcome back to LeetCode Daily Live where I do the daily question raw and then cuts. So we have a medium today. I did notice that the acceptance rate is very low today. So it's like 27%, which doesn't really reflect it being a medium, but we will see. So the question is called total characters in string after transformations 1. So what do we have? So we have a string s and and an integer t. So let's see what the lengths are. So string is just like usual, so 100,000, and it could only be lowercase English characters. The number is 1 to 100,000 as well, and we want to return an int. So so that's what we are given. So in one transformation, right? So t represents the number of transformations we have to do. So in every transformation, every character in S is replaced according to the following rules. So if character is Z, we want to replace it with AB. Otherwise, replace it with the next character. So A becomes B, B becomes C. So we want to return the length of the resulting string after exactly T transformations. Right. And it is saying that it could be very large. So that's why we have to like modulo it. So I guess we can look at some example first. So like for here, so because t is 2, that means like these are going to become z's in the first transformation, and then both of these are going to turn into AB. I think that's what. So we'll have like CDE, and then the first Y turns into AB after 2 transformation. The second also turns into AB. I guess we can. I was thinking of using a counter. Well, actually, it doesn't have to be a counter. We can just use like an array of length 26 to keep track of how many characters we have, and every time we just have to move, like for example, like the number of A's to number of B's and so on. Sorry about that. And then for the Z's, like we can just move all of that into like 1A and 1B. And because like we don't really have to like I'm thinking like if S is if the number of operations are even longer, like even more, my idea wouldn't work because like I have to loop through this every time, right? So I think like the even faster solution would involve using like something like matrix multiplication, but that's not to our concern here. And I think if we just simulate what's gonna happen, like, and we just step through the time, I think it should just work. So so let's just code it up. I guess we also have to deal with like the modulo stuff, but when we code it up, we'll find out how to do it eventually, or like what is needed to be done. So first of all, we definitely want to do mod, and then we also want to have a store. So we need an entry for every character. So for C and S, store, I think can do this to turn it back into. So like if you do this, the small letter A is going to turn into it's going to become 0 here, and then like B is going to become 1. So you just want to add 1 there, and then now for something in range T, so we want to simulate the simulations, right? So the first thing we want to get is the number of C's, I think. Number of C's. So that will be store -1. And now for I in range, so we want to move the number of Y to number of Z's, the number of X to number of Y's. So therefore, what we want to do is we want to loop from the back. So 24 minus 1, and then we want to step backwards. So we will have store, I think I'm not I minus 1. Yeah, just I plus 1 is equal to store I. And because we have stored the number of C here, it can be safely replaced by number of Y. And then like after you do that, it could be safely replaced by number of X and so on. So yeah, that's what we will do here. And then for the number of Z's, so for store 0, we need to set it to be number of C. For store 1, we need to add the number of C, because we will have transferred all the A's to B's, but like C turns into AB, right? So that's why like we need to add the A's that got transferred to B's, and also like the Z's that also contribute to B. So that's why it will be a plus equals here. And I think we just simulate enough times. I guess like another thing we have to do is we might want to modulo store 1, just to make sure it doesn't go out of bounds. And then at the end we just return the sum of store. Can we just, yeah, we can do that, and then we just mod. I think that should work. But yeah, again, the oops, where did I do wrong? This thing. Oh, is that not supported in Python? So if that's the case, I'll just use the ordinal function. Yeah, I think that might be a C++ thing. It's still saying that it doesn't work. So operand type. Oh, yeah, of course. I need to turn this into ordinal as well. So ordinal basically like turns the character into like its ASCII number. Yeah, but maybe I'm missing something, but I'm not sure why the acceptance rate is so low. I feel like, what? Okay, sure. Yeah. It could be like people forgetting to like do the mod, maybe. But yeah, I'm not sure why the acceptance rate is so low for this question. But yeah, I'll talk a bit about how I think of the solution. So, I guess like whenever you see something like lowercase English characters, and you have like some bounds, I think like the first thing I thought about is the time complexity, right? So because this is 100,000, it has to be like ON or n log n. But then we are also like the number of different characters we can have in the string is actually constant because of this line here. Like it is only 26. And so I thought of like whether to just simulate the results or not. So, and like when I think about like simulating the result, well, every operation, so every character will become another character, right? And like all of the same characters. So like if you have like a bunch of lowercase characters, if you have like a bunch of A's, well, all of these are going to turn to B's, right? So that's why like we can, for every unique character, well, we can just use a O1 like a constant time complexity to update it, and we only have a constant amount of characters. So therefore, for every move, so like every time step, I guess, you only have to do like 26 operations. Well, if you count this as like 2 operations, then it'll be 27. But my point is that it's constant every time, so that's why it works. Yeah, I guess that's it. And also, like, obviously, you don't really have to store the string because it doesn't like you're only keeping track of how many characters are in there, not the actual order of the string. So like that's why I thought of using a store to optimize, like instead of having to look at the string. Also, whenever you see something like, since the answer can be very large, you know that you can't store the answer in the string. So that's why like you probably have to think of other ways to represent the string, which in here it will just be a store. So yeah, um, I hope I also hope the quality of the video is higher, and I also try to make the characters a bit larger. So yeah, tell me what you think about the screen and stuff. Yeah. So yeah, I guess I'll see you guys tomorrow, and thanks for watching. So yeah, bye.